Mr. Hassan's Maths channel. I'm now answering a question from a paper, Solomon collection. This is Solomon K, the Mechanics M1 collection. And this question is taken from, or I've included it in my end-of-topic worksheet for my Cambridge Mechanics 1 end-of-topic worksheet, number 5, which is about momentum. So this is actually a Cambridge question, but it's especially as momentum is a new topic in Cambridge. It was introduced in M1 in Cambridge in 2020. So you don't have many questions, previously. I have any questions previous to that from the M1 in Cambridge. So I've taken some questions from other boards for my end of topic worksheet to leave the 2020 and post 2020 questions for the students to have to practice, when we do exams and stuff. So this is a question from a different board, all right, but it's relevant to what we do in Cambridge. The only difference will be at the end with the value of G, which we'll have to use for something, which we'll talk about then. So it says, in a physics experiment, two balls A and B of mass 4m and 3m respectively are traveling towards one another on a straight horizontal track. Both balls are traveling with the speeds 2 meters per second immediately before they collide. As a result of the impact, A is brought to rest and the direction of the motion of B is reversed. Modeling the track as smooth and the balls as particles, find the speed of B immediately after the collision. So you've got these two particles on this track. Okay, so you've got this track. Let's say this is the track. You've got the two particles, particle A and B. So let's say this is particle A. Just make that a bit different. Okay, so let's say this is particle A and this is particle B. Okay, this is particle A, this is particle B. A has a mass of 4m, so it's in terms of m, and B has a mass of 3m. Okay, they're traveling towards each other, so A would be going this way and B would be going this way according to what I've drawn on my diagram. And it says the speeds are 2 meters per second, so this is going 2 meters per second in this direction, and this 2 meters per second in that direction. So this is before the collision. Okay, so underneath I'm going to write what happens after the collision. So after the collision, what's going to happen is A is brought to rest. Okay, so this is going to be going at 0 meters per second after the collision. And B, its direction of motion is reversed, so it's going to be going in this direction. And we have to find the speed of B after the collision. All right, so we've got to find what that is. So now we can just use the fact that there's conservation of linear momentum. Okay, so we can say that the momentum before, the total momentum before the collision of both particles, okay, and the total momentum after is going to be the same. So the total momentum before or after is going to be the same. Okay, so the momentum before is going to be 4m times 2 plus, and you're going to have 3m times. Now this is where you have to be careful about your sign. So in this case, if we're going to take this side as positive, our velocity of B is going to be negative. So it will be minus 2 equals the momentum after, which would be 4m times 0, okay, plus 3m times the velocity of B, which we have to find. So we end up here with 8m minus 6m equals 3m times the velocity of B. So we end up with 2m equals 3 times mvb. So therefore, the velocity of B is going to be 2m over 3m, the m's cancel out. So the velocity of B is going to be 2 over 3 meters per second, and there's our answer. So even if the question didn't tell us about the direction of B, we could have deduced that the velocity of B is going to be such that B, of course, its direction has been reversed from this answer. Now, for part B of this question, it says a student notices that after the collision, B comes to rest 0.2 meters from A. Show that the coefficient of friction between B and the track is 0.113, correct to 3 decimal places. Now, in the worksheet that I gave to my students, this is for the Cambridge board, I adjusted the answer to be 0.111 because we use G as 10 in Cambridge and we use G as 9.8 in Excel. So I'm going to answer this question for both of those in the end. So basically what's happened is B after the collision is going to be coming to rest 0.2 meters, okay, from A, from the place where it had basically collided. all right? Because A has come to rest and B has gone in the opposite direction. So if this is where A is, B is going to start at this place, okay, and it's going to end up coming to rest, okay, 0.2 meters away from where A is. Okay, and its initial speed now we know is 2/3, okay, or meters per second. And its final speed is, of course, 0 meters per second. And it's come to rest in that, that distance of 0.2 meters. So we got to find the coefficient of friction between the track and between B and the track. So now what we got to understand here is, let's look at the forces acting on B. The forces acting on B are going to be its weight, which is going to be, as we said here, the weight of B is 3m. The mass of B is 3m, so its weight is going to be 3 mg. So the weight is 3 mg. You're going to have the reaction force because it's in contact with the surface, okay, which is R. It's going to be equal to 3 mg anyway. And then you're going to have the only force acting on it as it's moving is the frictional force, and that's F max because it is in motion. It is in motion, so the frictional force is the only other force acting on this, okay, and acting, okay, opposing the motion. It's moving in this direction, okay, and it's the only force acting is F max, which is opposing the motion. So if we know that F max is equal to mu R, so we can call this mu R. Okay, so we can say F max is equal to mu R, which is equal to, as we know, R is equal to mg. If we resolve the force 3 mg, if we resolve the forces upwards. So we can say F max, therefore, is equal to mu times 3 mg, which is going to be 3 times mu times mg. That's F max. Okay, so if we resolve the forces acting on this in the direction that it's moving, the forces are such that the force acting is acting in the opposite direction to which it's moving. So the force acting is going to be on the negative side. So it's going to be minus F max is the only force acting on it, and that's equal to the mass times acceleration, which is 3 times m times a. Okay, 3 times m times a. And that's the resultant force acting on this object. And we can say here that F max is equal to mu R, so it's minus mu, 3 mu times mg is equal to 3ma. The m's cancel out, so you're left with A is equal to minus 3 mu over 3, okay, minus 3 mu g, over 3. So the acceleration is minus mu times g. Now, that's the acceleration of this particle. So now what we're going to do is we're going to use suvat, because we have the distance it's moved, which is 0.2 meters. We have the initial speed, which is 2/3 meters per second. We have the final speed, which is 0 because it came to rest. And we have the acceleration, which now we know in terms of mu is minus mu g. Okay, so that's the acceleration of the particle. So what we can do here, we have S, U, V, and A. We can use V squared equals U squared plus 2AS. And we have V as 0. We have U as 2/3, so 2/3 squared, and we have plus 2 times minus mu times g times s, which is 0.2. Okay, in fact, what I'm going to do here to make it easier, I'll just rearrange this formula first to make it easier, and I'll make here, we have to find mu, so I'll make A the subject. So you have V squared minus U squared over 2S is equal to A. Okay, so we can say that here, we got V squared, which is 0, minus mu U squared, which is 4 over 9, over 2 times S, which is 0.2 times 0.2, and that's equal to the acceleration, which is minus mu times, we can put the G down here as well, by the way, put the minus 2 times, so that's going to be a minus mu, that's right. So now what we're going to have, we have 4 over 9 divided by 0.4 g equals, that's going to be negative mu, so the answer we have to, in the end, so that's going to be negative 4 over 9, so the minuses will cancel out. So you end up with mu equals 4 over 9 divided by 0.4 g. Now, depending on what you took g as. Now, in Edexcel, we'll take g as 9.8, so that the answer will come out exactly as it's supposed to here. So if you use 9.8, you have 4 divided by 9, 4 over 9 divided by, in brackets, 0.4 times 9.8, okay, which will give us the answer, which is 0.113, which is the answer which we are supposed to get in this particular question. But the question that I gave to my students, I modified it such that we're going to have the answer come out as 0.111, because if you use G as 10, okay, as you have to do in Cambridge, then you see the answer comes out as, if you use 10, the answer comes out as 1 over 9, which is 0.111. So if we use G equals 10, then mu is going to be 1 over 9, which is 0.11123SF. And there we have the answer to this question. Okay, so that completes this question. Question number 10 from the end of topic worksheet, momentum, from my Cambridge M1 collection. And it's question number, which question is it? Number 4 from the Solomon K collection of Edexcel Mechanics M1 papers. Thank you for watching. Other questions you want to find from the Solomon K paper, you can find in this playlist over here. Other questions you want to find from this momentum worksheet from my Cambridge collection can be found in this playlist. It will appear in this section over here. You can watch other questions about momentum from my Cambridge collection in this playlist, and you can subscribe to the channel by clicking on this link. Thank you for watching, and see you soon.